Hello students! So this video here is about triangle angle sum theorem, guys, with this one is probably going to be a fairly short and simple lesson. We'll talk about what this theorem says. We'll look at a few examples, and then from there we'll call it, guys. Your practice for this assignment will be included in tomorrow's, or better yet, and I'm talking to my students enrolled in my class at our school. But your practice for this one will be included in tomorrow's lesson, or again, probably that for you guys, that's probably Monday. But anyway, yeah. Okay, let's go ahead on and get started here. Okay, so let's go ahead on and start back over from scratch. Okay, so guys, some of you probably remember in one of our previous lessons, we went back to basics and we defined what a polygon is. And again, a polygon is a closed two-dimensional figure formed by three or more segments, which are usually called sides or edges. And so again, those segments in a polygon are usually called sides or edges. And again, guys, we also talked about in one of our previous lessons, even though most of us were probably already familiar with what a triangle was, just to make sure, we had talked about how the fact that a triangle is the smallest type of polygon with three sides and three interior angles. And then, of course, guys, we wanted to make sure that you understood exactly what we meant when we said interior angle. Guys, that is very important when we're going to be talking about this triangle angle sum theorem. But again, a triangle is the smallest type of polygon with three sides and three interior angles. Okay, so guys, before we get into the triangle angle sum theorem, again, I just want to give you a little bit more background and basics to make sure you've got everything you need before we go into this. Guys, I would be really remiss if I didn't go through the types of triangles that exist. And when I say I would be really remiss, I mean later on I would probably regret it or come to regret it if I didn't go over the basic types of triangles with you, or the types of triangle classifications when we're classifying a triangle by its angles, by what types of angles are there. And so, guys, most of us probably remember these three types of angles, and actually these are not the only types of triangle classifications that there are, but again, these are the types that I want to make sure we go over in this particular lesson as part of our background, I guess, information and reminding you of things that you probably should have learned in either elementary school or middle school. But anyway. All right, so again, folks, I do hope that you remembered these three ways of classifying a triangle by its angles, and so you should remember that an acute triangle is a triangle that has three acute angles. Now, for those who don't remember what an acute angle is, we're here to remind you. Again, it's not something that should be new to you. I'm talking to my students enrolled in my classes at our school. This should not be anything new to you. Again, folks, an acute triangle has three acute angles, three acute angles, interior angles, right? And so, and again, folks, an acute angle is an angle whose measure is less than 90 degrees, right? So an angle that has a measure that is less than 90 degrees. So in other words, for an acute angle, the measure is between 0 degrees and 90 degrees, but it has to be less than 90 degrees. Okay, greater than 0 degrees and less than 90 degrees. All right, we should remember what a right triangle is, because when we when we went over Pythagorean theorem and the distance formula, we talked about right triangles, right? And so we should remember that a right triangle is a triangle that has one right angle. And when we say right angle, we mean an angle that has a measure that is exactly 90 degrees. And again, folks, you should remember what that 90-degree symbol looks like. Either you'll see that 90-degree symbol, which looks like a box in the corner of the angle, or you'll actually need to see the angle measurement of 90 degrees written there for you to know for sure that it's a right angle. Do not assume that it's a right triangle just because the angle looks like it's a right angle. Folks, you do not know that angle is exactly 90 degrees unless you are told, unless you see a right angle symbol like what you see here, that little box in the corner, or unless it is specifically written in the diagram, like you would need to see it specifically written in the diagram, 90 degrees, like that right there, just like that right there. You need to be told, okay, this is a right triangle or a right angle that you're dealing with, or you need to see 90 degrees written there, or you need to see the little right angle symbol, okay, in order to know that it's a right triangle. Just a reminder for you, okay? Don't assume. All right. And then again for an obtuse triangle. An obtuse triangle is one that has is a triangle that has one obtuse angle. And folks, remember that an obtuse angle is an angle whose measure is greater than 90 degrees and less than 180 degrees. So in other words, an obtuse angle is bigger than a right angle, but it is smaller than a straight angle, smaller than a straight angle. And we know a straight angle looks like a straight line, right? So it has an obtuse angle has a measure that is greater than 90 degrees and less than 180 degrees. And an obtuse triangle has one obtuse angle. All right, so again, that should serve as a pretty decent reminder to you guys about these little basic things here before we go further and deeper into this lesson on the triangle angle sum theorem. So, folks, even though we've got these different types of triangles, okay, the triangle angle sum theorem pretty much tells us what all of the interior angles in a triangle add to. And folks, remember what an interior angle is in a triangle. Remember an interior angle. Wow, sorry, my bad. Yeah, it's just moving it all over the place. All right. Remember that interior angle is one of those three angles that are inside of a triangle. And I'm going to erase what I'm doing right now, like this one and this one, right? So the triangle angle sum theorem pretty much tells us what all three of those interior angles in a triangle are supposed to add to. Now, some of us probably already know and remember this because, if I'm not mistaken, this should have also been something probably, depending on what school you went to, what state you were in, or something like that. It's probably something that you've already heard as well. But anyway, if it's something that's new to you, that's why we're going over it. So that's what the triangle angle sum theorem talks about. What all three of those interior angles in a triangle are going to actually add to give you. So let's go ahead on and get into that. All right, so here we go, guys. Here's the triangle angle sum theorem. All right, so what the triangle angle sum theorem says, it says that the sum of the three interior angles in a triangle is always 180 degrees. Now, folks, again, don't get this 180 degrees twisted. Don't get it twisted. Don't get it confused. Don't get it mixed up with us talking about supplementary angles. We're not talking about supplementary angles here. We're not talking about two angles that add to 180 degrees, and we're not talking about like angles anyway. Okay, not in that sense. Like we're not talking about like angles like this. Now again, these three angles inside of this triangles, don't get it twisted. They are angles, but they're not like these types of angles here. These three angles that we're talking about are three interior angles inside of a polygon. Okay, so yeah, we talking about these three interior angles inside of this polygon, inside of this triangle. Okay, so please don't get this confused. Do not try to compare this to supplementary angles. Okay, where we're talking about two angles that add to 180 degrees that are not inside of a polygon like what we have here. Now here, guys, we're talking about for any triangle, which is a type of polygon, whether that triangle is acute, meaning that all three angles would be less than 90. So whether that triangle is an acute triangle where all three angles are less than 90, whether that triangle is a right triangle where it has one right angle, or whether or not that triangle is an obtuse triangle where one of the angles is greater than 90 degrees. Okay, so folks, no matter what type of triangle you have classified this as, for any type of triangle, the sum of all three interior angles is, and guys, remember that the word sum, or that word sum means, or that a sum is the result of adding numbers together, right? So don't forget about that right there, okay? For those who might be acting like they didn't forget. that the sum of something is the result of adding some numbers together. So please don't act like you don't remember what a sum is, okay? Just a reminder to remind you folks. Again, sum is the result of adding okay? So when we say it's the sum of the three interior angles, we're talking about the sum of the three interior angles as in when you add those three interior angle measurements together, it is always going to be equal to 180 degrees. Now, folks, here they already have this wonderful equation set up for you, because that's the representation of the triangle angle sum theorem. That again, when you've got any triangle, those three angle measurements add up and they equal to 180. The sum of those three angle measurements is equal to 180 degrees. There's no simpler way to say that. The measure of angle A plus the measure of angle B plus the measure of angle C, all three interior angles, the measurements add up to equal 180 degrees. You've got an equation there. All you'd have to do is plug in the parts that you know, whether those parts are numeric values, as in whether they're numbers, like 50 degrees, you get what I'm saying? 30 degrees. I mean, it ain't really gonna matter too much. 35 degrees, 75 degrees. So if they're numbers like that right there, I mean, they could be numbers like that: 50 degrees plus 35 degrees plus 75 degrees. You see what I'm saying? You see what I'm saying? Or they could be stuff like 5x, 4x minus 5. You get what I'm saying? You get what I'm saying? You get what I'm saying, right? You know what I mean? You know what I mean? You know what I mean? Y'all know what I'm saying here now. It'd be like 9x minus 15. Y'all get what I'm saying? So it can either be like numeric values, or it could literally be variable expressions there. But one way or another, guys, the sum of those three interior angles is going to be 180 degrees in any triangle, okay? And that is the triangle angle sum theorem. Now, folks, this is a simple concept, but guys, the different types of problems that you could see involving this, you can see a whole lot of different types of problems involving this. And guys, the problems involving this don't just have to have triangles in them. All of the stuff that we've talked about previously, about like all of those different types of angles, like for real, y'all, all those different types of angles, linear pairs, vertical angles, even the stuff with the parallel lines and the transversals that we talked about, my students enrolled in my classes at our school, all of those different things could be involved when we're dealing with using the triangle angle sum theorem. Because guess what? With the people who write this curriculum for our course, for this class, yeah, they've got all of this stuff together, and so they might put all of this stuff together for this one simple concept, where all three of these angles, interior angles inside of the triangles, add to 180. But they might add other stuff in the problems that they expect for you to know. And they'll want you to apply everything that you know to this, as well as applying this triangle angle sum theorem. So I'm going to show you a variety of different types of problems that you might see. Okay, so just bear with me here. Okay, yeah, I got y'all. Okay, I'm looking out for y'all. So again, we're gonna look at these different types of problems, because I don't want y'all to not be exposed to this, and then when y'all see it later on in the future, either in your next math course or on your final exam, if it's a state exam or even if it's a teacher made exam, you know what I'm saying? I don't want y'all to be surprised, to be like, oh man, I haven't seen nothing like this before, Mr. Starkey. What in the world is all of this, man? You ain't say the team was gonna put all of this in there. But guess what? Yes, I did. Alright, so here we go. We're gonna look at some examples. Yeah, sorry about putting all of that stuff up there on this diagram. I had to erase that. But now we're gonna look at some examples, alright? For real. Alright, so guys, here we go. This is example 1. And it's pretty simple if we get the basic concept of the triangle angle sum theorem. All right, so here it says find the missing angle. Right? So we see here that we've got a triangle, and of course this triangle has 3 interior angles. Right now, guys, you only see one angle measurement given, like precisely, specifically, like written out as like 41 degrees, right? So you only see one angle measurement given. However, guys, they give you more information than just that, right? Because here you can see that they put in here this right angle symbol, right? So you know that that's a right angle, right? Because they got that right angle symbol, which lets you know that this angle here is 90 degrees, and because this angle is 90 degrees, we technically know that this is a right triangle. Not that that's going to be important for us solving this problem, but we technically know that this is a right triangle because this triangle has one right angle, right? So we know that this angle here is 90 degrees. Okay, I'm not going to put that there. I'm going to put it here. Yeah. All right, so again, we know technically that we've got 90 degrees there, and we've got 41 degrees there, right? So we've been technically given 2 of these angle measurements. Of course, guys, you had to know again that this was a right angle symbol, which we've talked about. My students enrolled in my classes at our school. So again, they've given us 2 angle measurements, and we got to find the third one, right? So, guys, this is fairly simple if we know the basic concept of the triangle angle sum theorem. So, because this is a triangle, all 3 interior angles have to add to give us how much? I'm so glad y'all said the right thing. Okay, I didn't really hear y'all, but I'm assuming that y'all said the right thing, okay? Seeing as to how we just now talked about that. Yeah. All three interior angles in this triangle and in any triangle have to add to 180 degrees. All right, let's get this, y'all. All three interior angles. Now I'm just going to write this out for right now. All three interior angles in any triangle. I say in any triangle. Now, of course, I won't write this out for every single problem that we do, because I mean this theorem isn't going to change. It's not going to change. But just so you get my drift of every little thing that's going on here, I'm gonna write this out for this example right here. All three interior angles in any triangle add to 180 degrees. Okay. That's our reasoning here of what we're doing right now. Okay. So guys, since all three of these angles add to 180 degrees, guess what? Guess what that means? That means that the measure, yes, I'm going to write out the technical way of this. That means that the measure of angle G plus the measure of angle O plus the measure of angle D. Yeah, I'm writing it out. I'm writing it all out. I ain't just writing the numbers. I'm gonna write this out. Okay. Yes. Okay. I'm a mathematician. If you not, hopefully I'm training you to be little mathematicians or little young adult mathematicians, big young adults, little young adults. You know what I mean. All right. So the measure of angle G plus the measure of angle O plus the measure of angle plus the measure of angle D. All three of those interior angles there add and they equal to 180. Okay? So that's what we're doing right there. That right there is the triangle angle sum theorem. Now, folks, of course, we've been given two of these angle measurements. Wow, I see, I didn't even realize that spells God. God. Oh my God. All right. But anyway, so we've been given two of these angle measurements. We've been given that the measure of angle G is 90 degrees, so it's not a surprise that I'm putting 90 degrees right here, right? Okay, awesome, lovely. And we've been given the measure of angle O as well. The measure of angle O is 41 degrees. All righty. The only angle measurement that we don't know right now is this one, right? Now, folks, some of you will not want to put a question mark there, right? A question mark. Well, when you was in elementary school, they just had a box there, right? Okay, so you're not in elementary school no more. Maybe you don't want to use a question mark. Maybe you don't want to use just a box. Okay, use a variable, any variable as your unknown value. Then, okay, since you know algebra and you using variables now. Okay, then pick your variable, any letter in our little alphabet that we're using. And call it a day. Then, since you don't want to use a question mark like me or a box like me, then just make yourself another little variable to represent that. Then, okay, like X. How about that? How about them apples, oranges, bananas, whatever kind of fruit you like to eat, grapes. Okay. Alright, if you ain't too keen on putting a question mark there, alright, so just so you know, okay, for your information. Alrighty, so again, 90 plus 41 plus X, okay, as that third unknown angle equals 180 degrees. Now, of course, guys, we're going to solve this for X, and that'll be our missing and unknown angle. All right, and we're not going to take up your time solving that because we got more examples to show you. But again, folks, the reason why it took so long, oh God, really? Okay. Oh, whew, okay. Oh my goodness. All right, I'm sorry about that, y'all. The last time I pressed that thing that you just saw show up, yeah, it didn't go away, and I wasn't able to do anything else on my video. So okay. All right, good. I'm glad that it didn't do that this time. Lovely. Anyway, guys, I'm not going to take up your video time with solving that because that should be very, very simple for you to solve this. I'll just show what the answer is. All right, so again, folks, here x equals 49. All right, so that was our missing angle. We're going to look at some more examples. Again, folks, I want to show you a variety of examples with using this triangle angle sum theorem, because again, these problems could look a whole lot different than just this, and I want to show you quite a bit of different types of examples that you'll see, that you could see. Okay. Okay, so here we go. Example 2. All right, so again, we've got a triangle. This time, guys, in this triangle, we're not given like number measurements. I mean, we got variables, variable expressions. Oh man. Okay, well, they give us this right angle symbol there. That's the closest thing that we've got to a number, right? Because if this was a right angle, because of that right angle symbol, we know that this is actually what, 90 degrees right there. So that's the closest that they come there to giving us a number there. Okay, we'll take that. Yeah. All right. So again, folks, we've got all three angle measurements here, 90 degrees, and they tell us these other two, one of them is 2x plus 1 degrees, the other one is 5x plus 5 degrees, and so we need to go ahead and use our triangle angle sum theorem. The fact that all three of these angles add to give us 180 degrees, right? So let's go ahead on and set that up. If we know that all three angles add to 180 degrees, right? If we know that, then what type of representation can we write out? What can we write out? What type of expression or equation, really an equation, what type of equation can we write out that represents that all three of these interior angles, the 90, the 2x plus 1, and the 5x plus 5, that all three of these interior angles add to 180 degrees. So that when they add together, they equal 180 degrees, right? What type of representation can we write out? Okay? I mean, and that should make sense to you. If you know what the triangle angle sum theorem says, the fact that all three of these add to give you 180 degrees, that the sum of the three interior angles is 180 degrees, then it should make sense for you to be able to write out an equation that says just that all three of these angles, the 90 degrees plus the 2x plus 1 plus the 5x plus 5, all three of these angles have to add together. Okay, so when we do the sum of those three interior angles, it is equal to, or it is always 180 degrees. Okay? That's it right there. Okay? So again, folks, I ain't gonna write it out like I did all the way before, but again, folks, the sum of the three interior angles, that what we doing. I'm gonna write it out one more again, so nobody's confused. The sum of the three interior angles I don't think anybody should be confused, but just in case, you want to make sure that you got a good understanding of this right here, of the triangle angle sum theorem, and I want to make sure that you got a good understanding of it too. So you know what, we're gonna go ahead on and write this out. The sum of the three interior angles of any triangle is always 180 degrees. So right there where you see that equals 180, there you go. That's the reason why right there. Is always 180 degrees. is or equals, right, always 180 degrees. All the time, never not, but always is always 180 degrees. So again, guys, the sum of the three interior angles of any triangle, and this is a triangle, is always 180 degrees. So that's why we got this equation written out right here. All right, so that should make sense. Again, folks, I'm not going to take up video time solving that, but again, we're going to work it out, solve it, and I'll show you the answer for it, okay? All right, so here, folks, x equals 12. All right, so again, that was example 2. Where we had some different variable expressions, still fairly simple, right? We're going to look at some more examples. All right, so here we go with example 3, folks. Now, in this one, it's similar to example 2 where we have variables. Now, in this example, they're asking us to find the measures of all 3 angles. Now, in example 2, they ain't ask us for this. In example 2, they just asked us to find x. they taking this another step further right here. They don't want you to just find x. Now, again, folks, they want you to find the measures of all 3 angles. So, in order for you to find the measures of all 3 angles, first off, you're going to have to find x, right? Because you're not going to be able to tell me what the precise angle measurement is without knowing exactly what number actually, works for x, right? Yeah, you can't tell me what those angle measurements are unless you know what x is. So clearly, we need to use the triangle angle sum theorem. Big surprise, right? That's a shocker. The triangle angle sum theorem. Trying to act like that's what this lesson is about. Okay, alrighty, so let's go ahead on and do this. Alright, so again, folks, we got these 3 interior angles. One right here, one right here, and one right here. All 3 of these interior angles. And we know that they supposed to add to give us a total of 180 degrees. All 3 of those interior angles add to give us 180 degrees. Now, folks, I'm not going to write it out like I did in those last 2 examples, because by now, again, we should be remembering this, and that's why we're repeating this same thing over and over and over again to help get it in your memory, that all 3 of these interior angles inside of this triangle have to add to give us 180 degrees. All right. Let's go ahead on and work this out and solve it. Write out our equation that represents just that all 3 of these interior angles inside of this triangle have to add to give us 180 degrees. So we take the first angle, 8x minus 1, 8x minus 1. We add that to the other angle, right? 3x plus 4. Add that to the other angle, 3x plus 9. So all 3 angles added together, the sum of them, right? The sum of these 3 angles, all 3 angles added up, added together, they are always going to be 180 degrees when we got the 3 interior angles of a triangle. So there we go. We've got our equation. That equation came from using the triangle angle sum theorem. Again, folks, we've reiterated that in the past 2 examples. So again, nobody should be confused about where this equation came from. If you are still confused and still don't understand, give me a call, shoot me an email. You know what I'm saying? I've given you my contact information. So if you still need extra help, and again, we're not done with this video. I'm just saying though, if you still need extra help, my students enrolled in my classes at our school. I've given you my contact information, where you can still contact me, and we can go from there. Once you contact me, communicate, right? Because I'm not a mind reader, and I don't know unless you let me know that you need help. Anyway, All right, so all right, we're not going to take up video time solving this because again, folks, but at this time and stage in this class, my students enrolled in 9 classes. At this time and at this stage in our class, we should all be familiar with solving these equations. Yes. So, but again, if you need help, you know how to contact me. All right, we're gonna go ahead on and just work this out and show you the answer for it. Okay, so folks, x equals 12. But guess what? We ain't done yet. Nah, it ain't over yet. I thought I told you that we don't stop. I thought I told you that we won't stop. Alright, so again folks, we're not done yet. Because they didn't ask us to find x. I mean, we had to find x, but they didn't ask us to find x. Again folks, pay attention to what you're asked to do. Here they ask you to find the measures of all 3 angles. So again, folks, we haven't done that yet, so we're not done. We're not finished with this problem. So in order to find the measures of all 3 angles, we have to take this measurement of x that we just found, and we need to plug it in. Plug it in, plug it in. Oh yeah. Oh, we going there. We need to plug it on in. We need to substitute this value of x. And we need to go ahead on and use that to find out the measurements of all 3 of these angles. Okay? And so that's what we're going to do. That's what we're going to need to do right now. Okay, I didn't mean to write my U like that, but it's all good. Alright, so we need to plug in the value of x into all 3 of those expressions. And then we can go ahead on and know for sure what all 3 of these angle measurements really are. Alright, so one of these was what, 8x minus 1. And so when we go ahead on and plug in that x value there, 8x minus 1, right? For that one, this angle measurement here, again, if we plug in 12, 8 times 12 gives us 96, and 96 minus 1 is 95 degrees. 95 degrees. I said 95 degrees. 95 degrees. 95 degrees. Alright, that's one of the angle measurements, okay? Let's do the other one. Let's do the other ones. We had 3x plus 4. Okay, that is not a 4. Seriously? Alright, that's better. We had 3x plus 4. And so when we plug in here, plug in this, for this x, we're going to plug in our value that we found. We found x to be 12. So we're going to plug that in. Yes, we are. Oh, yes, we are. 3 times 12 gives us 36. 36 plus 4 gives us 40. Okay. All right, so we got 2 of the angle measurements. Guess what, folks? We got 2 of the angle measurements. Technically, we don't even need to even plug in x. For the third one, do y'all get what I'm saying? Do y'all get what I'm saying right here? Since we already know 2 of these angle measurements, y'all. I mean, do you really get what I'm saying here? Since we know 2 of the angle measurements, you get what I'm saying? You ain't really got to plug in. You ain't really got to plug in 12 for the third one. Do y'all really get what I'm saying when I say that? Because we got 95 and we got the 40, y'all. And all we need to do is to find that third angle measurement. Okay, hold on one sec, because I can't put the dot up there. There we go. There we go. There we go. Because all we need to do is find the third angle measurement right there, y'all. We don't have to really plug in 12 into that third variable expression. All we got to do, y'all, is add these 3 angles together instead of making them 180, right? I mean, that's really all we got to do. Seriously. I mean, if we knew 2 of the angle measurements, if we knew one of them was 95, the other one was 40 degrees, then if we just need to find the third angle measurement, yeah, we can literally just use that triangle angle sum theorem, right? I mean, if you don't want to go through the whole process of plugging in that 12 into that third variable expression, then yeah, you can just do this right here, okay? And again, that gives us 135 when we add these two together, and then when we take away that 135 on both sides of the equations. Again, folks, we can consider this question mark as a variable right now, okay? As an unknown value, whether it's X, Y, Z, whatever, whether it's a letter, whether it's some type of symbol, again, because a variable is some type of symbol that represents some type of value. So we can consider this question mark as a variable, just like X for right now, okay? So, okay, don't y'all start tripping on me, acting like you ain't never seen no question mark before. Anyway, when we subtract 135 from both sides of the equation, we end up getting this question mark, this unknown value for the third side length. Sorry, for the third angle measurement here. This unknown value right here has to be 45 degrees for that third angle measurement. $45 degrees. Yeah. All right, so folks, that is all three of our angle measurements. Okay, 95, 40, and 45. All right, that's all three of them right there. All right, all three angle measurements. That's all I'm trying to say. That's all I'm trying to say, y'all. You know what I'm saying? You know what I'm saying? Y'all know what I'm trying to say. That's all three of our angle measurements right there, you know? All three angles. That's all I'm saying. That's all I'm trying to say, y'all. You know what I mean? 90, 40, and 45. And that's it. Now we're not done with the video. I'm just saying that's it for this problem. Okay, I wanted that to sort of do that. There we go. That's what I wanted it to do. All right, I'm gonna show you now, guys. The next few examples that we're gonna do. Now I'm gonna go ahead and let you know up front. The next few examples, y'all. Next few examples gonna seem like they on steroids. They gonna be all bulked up. They gonna seem like they almost hulked out, like the Hulk. You know, they gonna seem like they on steroids as far as the difficulty level. But again, folks, I want you to have seen what different types of problems you could be asked to do involving the triangle angle sum theorem. So that's why I'm going to show you these difficult looking. Now they're not really all that difficult, but they may seem difficult looking, and they may involve more than just one concept. They may involve more than just this concept of what we're going through right now. So some of these problems that I'm about to show you are involving other concepts that we've talked about, dealing with other types of angles, special angle pairs, and special angle pairs that get involved when we have transversals and parallel lines and things like that. So just bear with me. I'm gonna explain it to you. I'm gonna explain it to you. I ain't leaving you hanging. Okay. All right, so folks, here we've got example 4, and this one here asks you to find the measure of the missing angles. And some of you are looking at this thing and you're probably saying, no, Mr. Starkey. Well, yes, how I'm gonna respond to that. Guess how I'm going to respond to that one? What I told you, huh? What did I tell you, huh? What I told you. Didn't I tell you that these that these next few problems was gonna seem like they was on steroids? Oh yeah, oh yeah. But anyway, folks, notice here that in this here problem, we've got 3 triangles, and if you guys see those 3 triangles, one of them, and guys, we're gonna break down. We're gonna, trust me, I ain't leaving you hanging, nothing like that. We're gonna break down each part of what we're doing, okay? So that you understand everything that's going on. Now, folks, if you try to look at all of this together, like if you try to look at all of this at one time, you are going to completely overwhelm yourself and not know what to do. So, folks, you're going to have to focus on one triangle at a time, on finding one part at a time, one triangle at a time, finding one part at a time, okay? Or even just using certain angle relationships that you know about. You're going to have to focus on one part at a time. And I'm going to show you that specifically, and because that's the way I'm going to explain it to you, one thing at a time, because I can't explain it all to you at simultaneously, because that just won't work. Hey, but anyway, let's work through it one thing at a time, okay? So folks, again, folks, we have 3 different triangles, and let's say that we are looking at, can y'all see what I'm highlighting there? I need to highlight that a little bit better than that. Let's say that we're focusing on trying to figure out some things about this triangle. Y'all see the one that I highlighted? Can y'all see that? I highlighted it yellow. Can y'all see that? Y'all see it? You see it? Okay. Oh, okay. You can see it. All right. I just want to make sure. Okay. All right. So let's focus on working out some things with this triangle. Now, folks, if we're going to do one thing at a time, the one thing that we know about this triangle right now is that 72 degrees. Okay. So here's the deal. Here's the deal. Joe Biden. All right. Not that he made up that whole phrase, but I've heard him say it so many times that anyway. All right, if we're going to focus on this triangle, let's look at that straight line at the bottom of that triangle, and guys, I told you that there's more than one concept in these problems. So the stuff that we've been talking about with these angle pairs and these special angle pairs, you'll see it, okay? And it may not be just one topic. It may be something that's involving multiple topics that we've talked about, like this, okay? So when you're looking at this angle there that says 140 degrees, okay? When we look at that angle and this angle that's right beside it, right? So if you're gonna look at them 2 angles right there, right, and look at that angle that's right beside that, okay, well these two angles, you should recognize what type of angle pair that is between these 2 angles that are coming together to form this straight line. Straight line, okay? How many degrees does a straight line have? And what are 2 angles called when they form a straight line? 2 angles that form a straight line are called a linear pair, right? The specific name that they get called. Now, they are other things as well. But again, they're a linear pair. A linear pair is also adjacent and is also supplementary. But again, folks, we know that a linear pair, because they form a straight line, adds to 180 degrees. So again, folks, at this stage of the game, you shouldn't have no problem with figuring out what this other angle has to be if we know that both angles have to add to give us 180, right? So some angle plus 140 has to equal to 180, right? So now I could write out. I could write out, you know, like a little equation. Is this angle right there? Okay, I thought that was gonna give me a box, a straight box, some type of rectangle like that. Okay, this angle plus 140 equals 180, right? You could write out the angle addition postulate, but you ain't got to do all that because most of us probably already know, right? That 40 plus 140 equals 180, right? So again, guys, this angle measurement here, right there, has to be 40 degrees. Okay, so this angle measurement right there is 40 degrees. Okay, so now we've used our knowledge about this linear pair that you see right there to find one of the other angles in this triangle. Y'all saw that? Did you see it? Did you saw it? Excuse my bad grammar. Did you see it? Did you saw it? Did you saw it? You saw it? Okay, good. Did you see it? Great. I do know how to use proper English. But anyway, folks. Okay. All right. So, folks, now that we got that angle, let's go ahead on and let's continue. Right. So now, let's go ahead on and use what we've got here, okay? Now that we know two angles in this triangle, okay, I don't like that. I sure enough don't like the way that look. Can y'all see? Can y'all see that? What I'm doing there? With that, I'm trying to put like a little arrow right here, but it's in highlighter. It's like a highlighter arrow, and I'm not really sure if y'all can see, you know, my highlighter arrow because it ain't like using a pen or something like that. It's a highlighter, you know. So y'all can see that arrow. Can y'all see it? Can y'all see that? I think can you? I think you can see it. I think so. All right. So again, folks, if we're focusing on that triangle and finding the third angle in that triangle, or finding angle 5, better yet, right? Now we can find angle 5. Right here, right? Yeah. Okay, yeah, that ain't what I was trying to do, but you know what? It's gonna be all right. Find the measure of angle 5 right here, right now. So now we can go ahead on and do that because we found, or now we know two of the angle measurements, and now all we need to do is find that third angle measurement. So 72 degrees plus 40 degrees, right? Plus the measure of angle 5, whatever that is. I'm gonna leave it written as the measure of angle 5 for right now, so we don't have a bunch of random variables here like X, Y, Z, W, Q, R, P, S, T, whatever, a bunch of random variables. I mean, the measure of angle 5 is the measurement of angle 5, so we can just leave it written as the measure of angle 5, right? Okay. All right, so 72 plus 40 plus the measure of angle 5 equals 180, right? For this triangle that I've got highlighted, okay, in yellow. Okay, that should make sense. And based on our last 3 examples, we should know where this equation came from. Okay, all right. So again, folks, I'm not going to take up our time solving for the measure of angle 5 because we can sure enough figure out what this third angle is. If you can't, then again, contact me, please, and I can help you. If my students enrolled in my classes at our school, that I've given my contact information to. But again, I do believe everybody in my classes should be able to find this third angle with no problems. All right, anyway. Okay, so folks, the measure of angle 5 equals 68 degrees. All right, now, that was only one of the missing angles that they asked us to find. Right? Oh, come on, Mr. Starkey. We ain't done yet. Are you serious, Mr. Starkey? We still got some more to do. I apologize if some of you are a little impatient with us not being done with this example, but we haven't found everything that they've asked us to find yet. So, excuse me. But let's actually answer the question before moving on to the next one, right? Okay, awesome. I'm glad you understand. Moving on. All right. So next, folks, let's look at another one of these triangles. Let's switch our highlighter color. Let's switch it to okay, yeah, why not? Why not? Yeah, let's go with yeah, that'll work. Yeah. Yeah. So I think that'll work right there. Yeah. That should work just fine. It sure should. Yes, it should. There we go. All right. Okay, so this triangle right here, right there, you see, I'm trying to color coordinate it here for you, so you know where we at, so you know what we doing here. You see what I'm saying? You see what I'm saying here? All right, so folks, I hate to bunch this up like this for this one example, but again, folks, I'm trying to show you the different things that we're doing here, so to figure out everything that they're asking us for. Yeah. Oh, by the way, and actually, before we look at this triangle, let's go ahead and find the measure of angle 4 real quick. All right, so guys, with the measure of angle 4, excuse me, you should notice that the measure of angle 4 is it forms a line with that angle, with that 72 degrees angle. It forms a straight line there, right? So if this one is this one is 72 degrees, right? Yeah, I know that's kind of sloppy looking. Sorry, y'all. All right, so that one is 72 degrees. Again, folks, these two angles form a straight line. They're a linear pair. Now, I'm not about to write linear pair again because, again, if you recognize one linear pair, you should recognize all linear pairs. And again, that may not be the case, but again, folks, alright, it's just gonna have to be good enough me saying it and not writing it. But again, so angle 4 and this 72 degrees here are a linear pair, and so that means that they add to 180 degrees. So folks, again, you should be able to figure out what this other angle is if you know that these two angles add to give you 180 degrees. So some angle measurement plus 72 adds to give you 180 degrees. Okay, so the only thing that works there is the fact that angle 4, the measurement of angle 4, has to be 108 degrees. Alright, and I'm not going to write that like that neither. I sure ain't. I sure enough ain't. I'm going to write it like this right here. We're going to use proper math terminology and symbols. The measure of angle 4 equals 108 degrees. That's it. That it right there. That it. Oh, that's it. Alright, so again, folks, the measure of angle 4 equals 108 degrees. Again, folks, because these two angles form a straight line, they're a linear pair. They are a linear pair. They form a straight line. A linear pair. Okay. Awesome. Alrighty. Alright, now let's focus on this triangle right here. So folks, with this triangle, you can see here, and I'm gonna try not to do too much here with different colors, but I ain't got much of a choice if I want y'all to see what I'm doing here. So I'm gonna go ahead on and just do it. You know, these two angles right here. Okay, I didn't want it to look that thick. Hold on one sec. Yeah, I really didn't want it to look quite that thick. Give me a sec. Give me a second. Give me a second here. Yeah, let's try that again. There we go. That'll be all right. Okay, still a little bit too thick, but it's all good. Right there. These two angles right there. All right. So that's what I'm about to focus on right there. That's what I'm about to focus on for you. Okay, those two angles right there. Angle 2. And this angle that is 135 degrees. Right? So it works the same way that we did these other ones, okay? These two angles are a linear pair. I'm not about to write that again because at this moment we should recognize that if these two angles form a straight line like they do. And like I said, guys, I know that this diagram has a lot in it, which is why I'm literally breaking it down into parts that are manageable. You see how I've drawn all these parts separately, and I've broken it down into manageable parts. And I'm not trying to look at everything together, but I'm looking at things separately so that it makes sense. Like this linear pair, I'm just looking at that to find one thing that I need to find out about that. We've looked at this linear pair, and now we're looking at a third linear pair separately from the diagram, just to be able to figure out certain little parts so that we don't get overwhelmed with the whole diagram. Okay, y'all get what I'm saying? Okay, so again, this right here is a linear pair. These two angles add to 180 degrees. Again, folks, I'm not going to write out an equation for it, but again, these two have to add to 180 degrees, which means that the measure of angle 2 has to be equal to 45 degrees. Okay, because that's the only way that these two form a straight line. And again, that's the only way that these two add to give us 180 degrees. Okay, 45 plus 135 equals 180. Yeah, that 45 just looks entirely too sloppy for me. I'm sorry, y'all. But we're going to have to, yeah. Okay, there we go. That's better. All right, so again, folks, the measure of angle 2 is 45 degrees. Okay, and so now, folks, we have found 3 of these angle measurements, missing angles. We got one more to find, and that's angle 3. Okay, so as of right now, folks, what I want us to do right here, right now, is I want us to I want us to go ahead on and no, I don't want that. Let's do orange right here. All right, I'm gonna highlight that in orange. Yeah. Now let's focus on this third triangle. And actually, folks, yeah, we're gonna focus on this third triangle. But yeah, and we're gonna look at some other types of angle pairs that's going on here. Yeah, right there. Alright, so this third triangle right here. Let's do it, y'all. Let's do it. Oh, by the way, before we get into this third triangle that I've highlighted with orange, let's find angle 1. So now that we know that angle 2 is what that is right there. What we say angle 2 was 45 degrees. Now that we know that angle 2 is 45 degrees. So now, folks, Now we can figure out what angle 1 is, okay? And so look here, for this triangle that I got here in pink, right here in pink, and I do apologize, y'all, about having so much written here. But again, folks, they wanted us to find so much, and I mean, I apologize if it's starting to look sloppy or starting to look unmanageable to you. I do apologize. I mean, yeah. All right, so with this pink triangle here, if you find that third angle in the pink triangle, first you'd have to find out what that third angle is before you can figure out what angle 1 is. Okay, so let's look at this pink triangle real quick, because I do want to show you at least one more example of how this thing could look. Yeah. Alright. Alright, so in this pink triangle, we know two of the angle measurements, two of the interior angle measurements. And again, folks, if we use the triangle angle sum theorem, we know that all three of those interior angles add to give us 180 degrees. So again, folks, I'm not going to write out that equation like I did in the previous in our previous examples. But again, folks, we know that all three of these angles add to 180 degrees. In this pink triangle, 60 degrees plus 45 degrees plus some unknown angle measurement have to add together to give us 180 degrees. So yeah. So if we go ahead on and work that out. 60 plus 45 plus something equals 180. Wow. Okay. And I do apologize about how that looked. If it looked real sloppy, I apologize. I'm sorry. I'm so sorry, y'all. But those three angles add together to give us 180 degrees. And again, folks, that gives us 105 plus this unknown angle measurement, that third angle measurement in there. Yeah, right there. Yeah, that one right there, that third angle measurement. Which is not angle 1, by the way. But yeah, that third angle measurement. Okay, yeah, we got to move that. I don't want to make a mistake and stop the video prematurely, and then I have to start over with this example in a new video. All right, so we subtract 105 from there. We get the measure of this third angle for this triangle, for this pink triangle right here. The measure of this third angle is what that is. What that is, y'all? 75. Alright, so the measure of this third angle here in this pink triangle is 75 degrees. Alright, so now that we know that third angle in this pink triangle is 75 degrees, then folks, what we need to do is we need to use that now to find out what angle 1 is. Okay, so now if we use that to find angle 1, alright, and I told y'all this problem was going to seem like it was on steroids. Okay, as in it's asking you to do a lot, and it is. I get that, but I told you guys you might see some problems like this, and that's for real. Okay, and so I just want you to be prepared. So yes, we're still on the same example. All right. So let's use what we got here to find the measure of angle 1. All right, so folks, right there, we got this these two angles, angle 1 and that angle that we just found to be 75 degrees right there. Yep, data 1 right there. So angle 1 and the 75 degrees. Okay, those two are a linear pair. They add to give us 180 degrees, which means that the measurement for angle 1, or the measure for angle 1, is 105, guys. Okay, I got to move that over or zoom out some, because I don't want to make a mistake and stop this video by mistake. That would not be good. Not at all. Not at all. Not at all. Alright. So again, folks, here the measure of angle 1 is 105. 105 degrees. Alright, so that's 40 angle measurements here that we found. And now, folks, we only have one other angle measurement there that we need to find as far as a numbered angle measurement, like you know, angle 3. All right, so let's do this. Let's focus on this orange triangle now. Excuse me. Let's focus on this orange triangle, and right here with this orange triangle, folks, there are two angle measurements that we sort of need to, well, not sort of at all. Two angle measurements that we need to find for real, that we sure enough need to find here. Let's see, what can we do here? You know what? You know what, y'all? Why not go ahead on and just do orange. Okay. So folks, with this triangle, for us to figure out the missing angles in that triangle. Okay, so for that one right there, give me a sec. I don't really like that because I'm gonna need to do more than just that. So let me give myself a little bit more space. All right, we'll use this part here. All right, so folks, in that orange triangle, to find those missing angles, you have to recognize what you're looking at. So guys, when I said that there's multiple concepts involved, so we've seen here that the concept of linear pairs was definitely in this example, right? So not only is that concept of linear pairs in this example where you had to recognize and know about those linear pairs. Okay, folks, right here, we've got vertical angles. We've got vertical angles here. All right, so that angle measurement right here, that I guess I can put right here as an orange, I guess, hopefully, without messing that up too much. As an orange, there, orange question mark, yeah, right there, that angle. So we know what we're looking at here. Alright, so that one, that interior angle for this orange triangle, if we wanted to find that, guys, we would have to know about these vertical angles, these two vertical angles here. So guys, the vertical angle for this one right here was this angle that was over there, that we knew, or that we found to be 45 degrees. So guys, remember that vertical angles are always congruent. So I'm gonna put these congruent symbols here. Again, vertical angles, the measurements for two vertical angles are always congruent to each other. So yeah, okay. All right, close enough now. Congruent symbols, right? Because these two vertical angles that I'm showing you right here that I've marked with these congruent symbols, vertical angles are always congruent to each other, always have the same measurement. Wow, what is that? Always congruent. Okay, yeah. All right, so again, folks, since we know that, that means that we shouldn't have to do too much explaining about what this angle here has to be. If we said that vertical angles are always congruent, right? Now, folks, remember that congruent means that they have the same measure, right? Because we talked about that. Congruent, same measure, right? Same measure. So if one of these angles is 45 degrees, that means that this other vertical angle with that is 45 degrees. So now, folks, we do know that this angle measurement here is 45 degrees. I do say that this angle right here is 45 degrees. Now, that's not the angle, that's not the measure of angle 3, but again, folks, we needed to find out what this angle was. And this isn't the only other thing that we need to find too. Wow, that is so sloppy, but you know what? I think you all can read that. 45 degrees. All right, cool. So this angle measurement here has to be 45 degrees, and we needed to know that. So that's 45 degrees. I'm gonna try not to take up too much space with that right there. Okay, so folks, the same way that these two angles with that little question mark were vertical angles. Okay, that's not the only set of vertical angles that we have in the diagram. Guys, in that diagram, in the same diagram, we also have another set of vertical angles, and that other set of vertical angles was that pair. And again, folks, I'm not trying to make this look all jumbled up like it is looking, but again, folks, I told you that this problem is sort of kind of like on steroids, where it's asking you to do a whole lot, and it's got a lot of concepts in there. I tried to warn you. All right, I really did. I did. Okay. All right. Again, folks, if we break it down into manageable parts, like what I'm showing you here, it's doable. Again, folks, the concepts are the same concepts that we've talked about. Okay? And again, folks, sometimes you got to put it together. And we know that again, in math, these concepts, they build on each other. So anyway, I'm just saying. All right, so here we got this other set of vertical angles. This one here was 72 degrees. Let's go ahead on and do this here, so we can look at our last example for this video, and then we're gonna call it quits. Okay. But again, I want to show you different types of examples of how this could work with using the triangle angle sum theorem, and that's what we do in here. So again, we fulfilling our purpose here of showing you the triangle angle sum theorem. Okay, you might not like this example, but it's okay. You ain't gotta like it. to know how to do it. You ain't got to like it for me to show you how to do it. All right, 72 degrees. All right, so again, these are also vertical angles, which means that this angle measurement here that I'm putting right there. Okay, I'm gonna have to color code that differently as well. Not that I have to color code it differently, but I am because I don't want it to get it mixed up with any of the other ones that we've got there. So let's go with light blue. Yep. Excuse me, guys. Yeah. I think I heard somewhere in the science class that when you yawn, your body is trying to make sure that your brain has enough oxygen. Yeah. It could be a symbol, a sign that you're sleepy or tired, but I think I heard somewhere in some type of science class, somewhere that your body is doing some type of autonomic response to make sure that your brain has enough oxygen onto it. Anyway, we ain't talking about that right now. All right, so guys, that angle that I've marked as light blue, as a light blue question mark. Okay, and why y'all let me put it right there for? Y'all know I wasn't trying to put that angle right there. Come on now. Why y'all let me do that? It's okay. It's all right. We got it. There we go. All right, so again, that angle that I've marked right there is a vertical angle with this 72 degrees. So again, folks, that means that this angle has to be the same measure, right? So this angle has to be 72 degrees right here. So folks, we have found both of these angle measurements in this triangle. But again, folks, we are not done. We are definitely not done, okay? Because again, we haven't found the measure of angle 3 yet, which is why we're doing what we're doing right now, so that we can find the measure of angle 3. Okay? So now that we know both of these angle measurements here in this triangle, let's go ahead on. Let go ahead on and solve for this third angle measurement here in this triangle. Let's go ahead on and do that. Let's do that right now. And I do mean right now. I mean right now. Okay, so folks, in that orange triangle, now that we've got these two angle measurements, the 45 degrees right here. What was that? Light blue. I ain't got the color coded now, but I am still. Alright, we had that 45 degrees right there, and oh wait, that wasn't light blue. Why y'all let me put that like that? And we had the 72 degrees. Alright, we had the 45 degrees and the 72 degrees. Wow, okay. And then, folks, we had to find out what the measure of angle 3 was supposed to be, which was that third angle there. So, folks, now what we need to do is go ahead on and go ahead on and do that. All right. So again, I'm not going to take up much more video time here. We're going to look at we're going to look at one more example after this. But again, all three of these angle measurements here add to 180, add to 180 degrees. Give myself a little bit more space there. Plus the measure of angle 3 equals 180. Yeah. All right, that right there gives you 117. 117 plus the measure of angle 3 equals 180. So subtract the 117 on both sides, and we end up getting that the measure of angle 3 has to be 63 degrees. And folks, that right there is the last thing that we had to find for this example. Alrighty, one more example and then we're gonna call it quits. Okay, so folks, here we go. This is going to be our last example for this lesson involving the triangle angle sum theorem. Here, folks, you see this triangle there, and you should also recognize something else that's in this triangle. Now, again, folks, I told you that these examples were going to look like they were on steroids, okay? But I want to make sure that you know how these types of problems could look and what types of concepts could also be involved with them. So, guys, you should recognize something else in this diagram. You see that right there? Y'all see that? Yeah, you see it. Oh, you see what I see, don't you? You see them 2 marks right there. Okay, yeah. I want them to look the same, but it ain't got to, I guess. It's okay. But y'all see them 2 marks. You know what? It's going to be all right. So y'all should recognize those 2 marks as parallel marks, right? Those like little arrowhead symbols that are right there, right? Y'all should recognize those as parallel symbols. And so again, folks, because we've got 2 parallel lines here, 2 parallel lines, and guys, there are multiple transversals here, guys. That's the other concept. So that's one of the concepts here that's involved. Oops, give me a sec. We got parallel lines with transversals involved with this one. Not only is it involving a triangle where we need to figure out the sum of the, use the triangle angle sum theorem, but it also involves parallel lines with transversals. And we've done a lesson on parallel lines with transversals. So again, folks, it's necessary for us to know everything that we've talked about, and to be able to even put it all together. All right. But again, you don't have to put it like this. You don't have to think of it all at the same time. You can break this problem up into manageable parts, which is what I'm going to show you how to do. Just like what I did in that last example. Folks, I apologize if it seems like it take a while to explain it to you. But again, folks, you'd rather I take the time to explain it to you than to just tell you the answers. There wouldn't be no need for me to make this video if I wasn't going to take the time to explain it to you. So again, I apologize about the length of the video, but again, my students enrolled in my classes, again, there's no need for me to make this video for you if I'm not going to explain to you how to do it, and explain why these answers are the way they are. So again, all right, let's go. Parallel symbol, right? So we got these 2 parallel lines. Now, folks, with this one, what the place where I suggest that we start off in this problem is, and really that it's going to really be the only thing that we can do initially. Well, not the only thing, but the most simple thing for us to do initially, y'all, is to use this thing right here. Y'all see these two angles right there? That's a linear pair. Those 2 angles right there, that's a linear pair that adds to 180 degrees, right? That's supplementary. So those 2 angles, they form a straight line. Right? You can see that. They form a straight line. These 2 angles are a linear pair. So let's go ahead on and if we go ahead on and find what this angle is, then that's one of these answers that's done and over with already. We got it. Once we find that right there, you know what I'm saying? Yeah. Now, folks, let's do this. Okay, where we at? Where are we? They add to 180. All right, so if they add to 180, then we know how to find what the other angle is. 140 plus the measure of angle 2 equals 180, which means that the measure of angle 2 has to be 40 degrees, right? So that's one of our answers already done, over with, right? This one was a linear pair. Yeah, I didn't want to take up all of that space. I apologize if that looks sloppy the way that I got that written. I apologize if it looks sloppy, but yeah. But again, folks, that is a linear pair, and we have found the measure of angle 2. All right, so now, folks, is where these parallel lines and these transversals come in. All right, so folks, you see here, we're not going to try to look at everything at one time. We break it down into manageable parts. So first, we looked at something that we could find, right? So that linear pair, that's manageable, right? If you recognize that is a linear pair. And now, folks, we're going to look at something else, another portion of this with the parallel lines, right? So let's look at these two parallel lines, parallel. That's how you know I'm tired, if I start doing all that right there. Anyway, we're going to look at these two parallel lines, and we got this transversal right here. Okay, that ain't really how that transversal look, but that's a little bit better. All right, and we got that transversal right there. All right, so all right, guys, we got two options. Yeah. Honestly, folks, right now we need to figure out what angle 10 is. We know that angle 9 is 80 degrees, so we don't have to find that. And really, guys, with problems like this, folks, you want to try to figure out one thing at a time. But folks, you want to find as much information as you can. Okay, one part at a time. So we've already found that angle 2 is 40 degrees. So honestly, folks, we can use that. I mean, we could have used the 140 degrees with angle 10 to figure out because these two angles right here are consecutive interior. And I apologize if that looks especially sloppy. I do apologize. So these two angles there are consecutive interior angles, which means that when we have two parallel lines like what we've got here, because again these two lines are parallel and they have the little parallel symbols there letting us know that these two lines were parallel. Okay, so again, because the two lines were parallel, those consecutive interior angles had to be supplementary or had to add to 180, add to 180 degrees. So that's one way that we can find the measure of angle 10, or folks, we can use angle 10 with the 40 degrees, because if we use angle 10 and the 40 degrees, then these two are alternate interior angles. And again, if these two lines are parallel, and we know that they are, then alternate interior angles are going to be congruent or have the same measure. Congruent or have the same measurement, right? Supplementary or add to 180, right? Congruent or have the same measurement. So we know. I mean, it ain't like by now we should know what congruent means, and we should know what supplementary means, right? So, but again, just in case there's somebody that don't know it out there, or just in case there's somebody that still need to see this, I'm writing it, okay? So you know for sure of what I'm talking about with this, okay? All right, so again, folks, one way or the other, the measure of angle 10 is 40 degrees, okay? All right, so again, I'm not going to write out any equation or anything like that, because that should be enough of an explanation to explain why the measure of angle 10, even though that's not one of the angle measurements that they wanted us to find, we still need to find as much information as possible, guys, to be able to find out what angle 11 is. Trust me when I tell you, you always want to find as much information as possible, because the more information you have, the more information you should be able to figure out later on. You know how they say knowledge is power? Well, in math, that is so true. The more information you have about a diagram, the better off you are as far as with figuring out the missing parts or with figuring out stuff about the diagram. Alright, so again, folks, here, the measure of angle 10, I don't know why I even put that in that little box. Yeah. The measure of angle 10 is 40 degrees. Alright, so folks, now that we know what the measure of angle 10 is, we should be able to find out what the measurement of angle 8 is, and I'm going to show you that just momentarily, because again, we're using the information that we know to find out more information about this diagram, and that's what we have to do, okay? So now we know that angle 10 is 40 degrees. I apologize if it seems like this video or this example is taking too long for those who might be impatient with me, but again, folks, I'm just trying to show you how to do this, okay? And if that takes time, it just takes time. All right. So angle 10 is 40 degrees. So now, folks, what we want to focus on is let's focus on the fact that we have a straight line here. All three of these angles form a straight line, and a straight line here between all three of these angles, or in other words, all three of these angles right here form a straight line, which is 180 degrees, right? Straight line always measures 180 degrees. Any straight angle measures 180 degrees. So all three of those angles there add to 180 degrees. Straight line, straight angle, whatever you want to call it. It's technically the same thing. It's a straight angle that happens to be made up of three separate angles, but it is still a straight angle. It's a straight line, it's a straight angle, whichever one you want to write, but it's equal to 180 degrees. That straight angle right there is equal to 180 degrees. Okay, if y'all are looking at what I'm looking at, and of course I'm about to draw that out separately, just to show you what we're talking about with this. Again, right there with that straight angle. Alright, so here, again, folks, we got that straight angle. Okay, yeah, that ain't no straight angle. Give me a sec, y'all. I'm going to have to pull out my ruler here. So we actually got a straight line to look at, right? Alright, so we got a straight angle, and we got these three different parts, these three different angles that are making up this straight angle. Yeah, you know, that's going to have to be close enough. It ain't got to look exactly like the diagram up there looks, but again, as long as we can see what it looked like, you know, I'm fine with that. Alright, so this angle here is 40 degrees, this angle is 80 degrees, and if we know that the whole thing is supposed to be 180 degrees, right, because it's a straight angle, and the whole thing, again, folks, the whole thing is supposed to be 180 degrees. Wow. Trying to make like a little semicircle there. Right? The whole thing there is 180 degrees, right? All three angles should add together to give us 180 degrees. Wow. Yeah. They know I wasn't trying to do that. It's all good. And we know two of those. Alright, so again, all three should add to give us 180 degrees. Again, folks, if we write that out, the 40 degrees plus 80 degrees plus another angle has to equal 180 degrees all together, right? 40 plus 80 plus the measure of angle 8 equals, wow, okay, I thought it was going to do that. Okay, I guess I need to move it up some or zoom it out some. Yeah, not that much. That right there equals 180. Those three angles added together equals 180, right? And so that's 120 plus the measure of angle 8, which means that the measure of angle 8 has to be 60 degrees. Alright, so again, folks, here the measure of angle 8 has to be 60 degrees. In order for that to work. Alright, and again, that was because we had a straight angle, and again, that straight angle was 180 degrees. Alright, any straight angle, any straight line has a total of 180 degrees, okay? And so, let's move on here. Alright, so we know that the measure of angle 8 is 60 degrees. Folks, we can use that. We can use the measure of angle 8 to get us the measure of angle 11. And actually, we can use the measure of angle 8 to not only give us the measure of angle 11, we can also use the measure of angle 8 to give us the measure of angle 12 as well. And so let's look at that real quick. Wow, okay, I didn't want to use that color, but it's all good. I'm just gonna go with black for right now. Yes, this is the same example, folks, because they asked us to find the measure of angle 2, which we have found, and we used to find other information, and now we're trying to find the measure of angle 11. But we had to find other information and use multiple concepts to do that, like alternate interior angles or consecutive interior angles with parallel lines, and like the fact that a straight angle equals 180. Anyway, all right, so folks, here, if we want to find the measure of angle 11, yeah, okay, I'm gonna have to use my ruler again. Y'all excuse me for a moment here. Okay, yeah, I'm not gonna. Yeah, okay. And you know what? Forget about that. It's just gonna have to be crooked, y'all. Cause I gotta do 2 of these. Well, I don't have to do 2 of these, but I want to show you want to show you again that we can use angle 8 not only to find the measure of angle 11, but we can use angle 8 to find the measure of angle 12 too. Yeah. All right, so again, angle 8, we had that the measure of angle 8 was 60 degrees, right? All right, and so we knew that. Oh, oops, give me a sec. That wasn't what we were trying to find here. All right, yeah, we had that at 60 degrees, right? That was 60 degrees. This was 60 degrees for angle 8. And so again, folks, if we needed to find angle 11, we could use the fact that these are two parallel lines. Wow, okay. The fact that these are two parallel lines, and the fact that angle 11 and the 60 degrees are alternate interior angles. And again, when we have parallel lines cut by a transversal, your alternate interior angles are going to be congruent, just like we mentioned up above there. Or in other words, they're going to have the same measurement. So again, if this angle was 60 degrees and they're alternate interior angles with parallel lines, that means that the measure of angle 11 has to be 60 degrees. Now again, folks, they didn't ask us to go this far, but seeing as to how you know, we trying to find as much information as we can, I'm gonna go ahead on real quick and just show you this here. It ain't too much, never too much, never too much, never too much. Thank you, Luther Vandross. Okay, let's see here, where we at? Angle 12, right? So if we had to find the measure of angle 12, again, the 60 degrees and that angle 12 are consecutive interior angles, or same side interior angles. And so again, just like we mentioned up above, because these two lines are parallel, then your consecutive interior angles are going to be supplementary, which means that they're going to add to 180 degrees. And so if that's the case, and if these two angles add to 180 degrees, okay, 60 degrees plus what equals 180 degrees, right? So 60 degrees plus 120 adds to 180 degrees, which means that the measure of angle 12 has to be 120 degrees. Folks, that's all. That's really it. I do apologize about the length of the video. However, folks, because we wanted to show you several types of examples, and it takes time to explain this, to make sure that not only that I'm just working it out, but making sure I'm giving you the reasoning and the explanation behind it. So folks, that's all. I hope this has been helpful. That's it. Good night. Bye-bye. Triangle Angle Sum Theorem and other concepts that could be included in it. Good night. Bye-bye.